Okay, so we're going to check out graphing linear inequalities. Now, this shouldn't be too terribly scary because hopefully by the time you get here, you're pretty good at graphing linear inequalities. So that would mean, I can't spell, but that would mean doing something like if I gave you x plus y equals 7, that would be a linear equality. I'm going to try better this time. A linear equality. And so you think, okay, I can graph that because I'm kind of awesome at things. So I know I want to get into this like y equals mx plus b form with the slope intercept form thingy. So I want to get the y by itself. So I'm going to go ahead and subtract x from both sides. And that gives me y equals negative 7, or negative x plus 7. And I'm like, oh, okay, well, I can do this. So that gives me a slope of negative 1 and a y-intercept of 7. So by a slope of negative 1, that means that, see there, here's like this little negative sign, and there's kind of like a secret coefficient of a 1 right there. So like it's negative 1 times x. So the slope here is negative 1, that's where that comes from. And the y-intercept is 7, which is that b thing. So slope is rise over run. So since it's negative 1, we could say it's negative 1 over 1, or we could say it's 1 over negative 1. So you can say however you want to do it. Either one is going to get you the same answer. And the y-intercept is 7. So we get ourselves a little graph right here, except we should do a better job of it. Okay, the y-intercept is 7. That means we go up 7. 1, 2, 3, 4, 5, 6, 7 right here. 7. I'm going to mark it 0 at 7 because it's 0 over 7 up. Now the slope is negative 1, 1. So I could say I go down 1 over 1. Down 1 over 1. That's doing it that way. Or I could say I could go up 1, back 1. Up 1, back 1. Up 1, back 1. And either way that I choose to go, I actually get this lovely line here. Oops, except I, should be better at connecting dots, but to be honest, that's kind of hard. So I've got graphing. That's an actual equality. So in order to graph linear inequalities, you have to be good at graphing equalities. So all I'm going to do is I'm going to change this just an itty bitty bitty bit. And I'm going to say, okay, well, what happens if it turns out that this question, instead of being x plus y is equal to 7, what if it was x plus y is less than 7? So let's check that out. Okay, so actually it's going to be very similar to get started. I'm going to put this together. Is less than 7, so let's see. I still got this 1, 2, 3, 4, 5, 6, 7, the little point there. And then I've got my little lines here, down 1, over 1, down 1, over 1. Terrible, terrible picture, but I'm going to give it a shot. Except I should try even a little harder. Like that. Okay, now I mirrored it a little early because I probably shouldn't have mirrored it. Instead of doing like a hard line like that, because it's not actually equal, see how it's strictly less than? That means I'm not actually equal to that. So instead of doing a straight line, I'm going to do what do you call these things? Dashes? Dash lines. So now I have dash lines instead of a hardcore line. Because I'm like, well, it's not actually equal to 7. It's like less than it. But, whatever. So now what I want to know is like, okay, well, I know for sure that my answer is not along that line. But I want to check and see if other areas might be. So I'm going to look in here and say, okay, well, here's an option. This could be one of the solutions to this inequality. So 0, 0. So 0, 0 means that x is 0 and y is 0. So I can say, okay, 0 plus 0, is that less than 7? Well, I had to think about that for a second. Yes, yay! Wait, I can't spell. Yes, it is equal to 7, so I get excited. Okay, so that's a good one. I'll make it darker. What about this point here, which is 0, 1? So that would be x is equal to 0, y is equal to 1. X is equal to 0, y is equal to 1. Is that less than 7? Oh, yes it is. Yay! Okay, now believe it or not, I could pick like a bazillion problems or points all around here. Let me get up to 6. What if I pick 0, 6? So if I pick 0, 6, that means that x is equal to 0, y is equal to 6, and you're probably getting the pattern right now. 0 plus 6 is indeed less than 7. So that's part of my solution set. So actually, anything that I pick in this section here is going to be an answer. And if my little highlighter thingy were better, I would do a much better job of, like, you know, making it pretty. Meow, kind of pretty. Kind of pretty. Alright, so like that. So I can say that anything in that section is going to be a solution. Okay, but what if I'm on the other side of the line? What if I pick a question out here? Like, what if I pick, let's get rid of these guys. What if I pick like 10, 10? And 10, 10 is going to be out here somewhere. So x is 10 and y is 10. Why did I pick 10, 10? I don't know, because I'm really good at adding 10s together. So I'd say, is 10 plus 10, is that less than 7? Well, no, because it's 20. No! And actually, anything that I pick on this side is going to give me a no. So what I've done is I've actually shaded in and shown you that x plus y being less than 7, anything in this section here is going to meet those requirements. So that's really all there is to at least graphing linear inequalities and doing stuff like that. So let's actually look at a more complicated problem. So I've got a problem that looks like 2x minus y is greater than or equal to 3. This is actually kind of as ugly-ish as you can make it be, which is unfortunate, but we'll play with it, okay? So if I say that 2x minus y is greater than or equal to 3, all right, well, my first step is going to be to actually graph it. So in order to graph it, I need to get a little y and x plus b format. So I'm going to go ahead and get the y by itself. So I'm going to subtract 2x from both sides. So that gives me minus y is greater than or equal to minus 2x plus 3. Now I have minus y, and I really, really wish I had plus y. So I'm going to multiply the whole equation, or both sides of the equation, by negative 1. Now you may remember that whenever we multiply an inequality by negative 1, that means that we have to switch the sign. Okay? So, and I'll do an example of y in a sec. But take me for my word for a second. So we have to switch the sign. So negative 1 times negative y will give me that positive y I want. I have to switch the sign. Then I've got 2x minus 3, because I take this guy and I go whoop-shoo and whoop-shoo. So if I apply that negative to everything, I get y is less than or equal to 2x minus 3. Now if that's bothering you, think about this again here. What if instead of subtracting the 2 or the 2x from both sides, that I decided to add a y to both sides? If I'd added a y to both sides, I would have had that 2x is greater than or equal to y plus 3. And then I'd say, wait a second, I want to subtract 3 from both sides. Then I'd have that 2x minus 3 is greater than or equal to y. Or if I kind of like read backwards, I could say y is less than or equal to 2x minus 3, which is exactly what I got here. So the whole switching the sign thing, it's not just like when I first heard it, I thought people are just like making stuff up. And I just follow directions, so I do what I'm told. But there is a real reason behind it. So just to make sure that you keep that in mind. I'm doing that. So I'm going to go ahead and erase that. That's why YouTube is amazing. I'm just like, no, don't erase it. In real life, it'd be like, too bad. But in amazing virtual life, it'd be like, haha, I can go back and look at it again. You can't stop me. So I have y equals 2x minus 3. So my slope, actually, if you have a chance, you should like pause this video and see if you can go graph it and stuff, because then you'll know you got it, because you can come back and I'll do it and you'll be like, yeah, I'm amazing. So like, assuming you did that, slope is equal to 2, because that's the number in front of the x. The y-intercept is going to be that negative 3. So let's try a little graphy graph. I don't know what's going on here. Minus 3. My y-intercept is at negative 3. So right here, my slope is 2. So again, remembering that that's rise over run. So that means I go up 2 and over 1. Up 2 over 1. Up 2 over 1. And I'm going to draw this in. Now the question is, do I want to draw this in as like a hardcore line, or do I want to do a dash line? If you said dash line, no, sorry, if you said solid line, that means you're right. In this kind of equation, I actually want to do a solid line. So I'm actually saying no for realsies. The answer is right here along this line. Why is it right here along this line? Well, because it's, what do you call it, equals. Oops, except I deleted it. It's a less than or equal sign. Up here, we specifically had that x plus y was less than 7, but it wasn't equal to 7. So we put that dash line to indicate little dashes indicated that it wasn't actually equal. But in this case, it is. It is not only equal, but it is also less than. So that means that we can go through here and we can pick kind of whatever we want. Now the question is, which way do we shade it? The best way to decide, I usually just pick 0, 0 because it's easy to do math in 0, 0. And then I'll pick something on the other side of the line. So I don't know what you could pick. You could pick, looks like 3, -3 would be on this side. And if you're not sure, like, well, maybe it isn't, pick something really ridiculous. You know that 100, except you can't see me, you know that 100, -100 is definitely on this side of the line. So pick that one because, you know, why not? Might as well. So let's check 0, 0 first. If I check 0, 0, does that satisfy this equation? So you can either use that equation or you can use the original. Sometimes people like to go back to the original equation just to make sure that they've got it right. So I'll do that. So I have 2 times x, which is 0, minus y, which is 0. And I want to know, is that greater than or equal to 3? All right, 0, is that greater than 3? Well, no. So that's not on the side that I want to shade. Now, maybe I did something goofy, so let me go ahead and check the other side, the other point. So I have positive 100, negative 100. So I have 2 times x minus y. Now this is where you gotta be careful because y is a negative 100. So it's minus a negative. Is that greater than or equal to 3? All right, so I have 200 minus a negative would be plus 100. Is that greater than or equal to 3? Yes. So I have 300 is clearly greater than or equal to 3. So this is a happy one. So that means that I'm actually going to, whatever you call it, shade in everything that's on the happy side. Now there's rules about, oh, well, if it's a greater than, then it's going to be on this side, or if it's less, then it'll be on this side. But then I always get them mixed up and kind of confused. So really the best way to do it is just to say, I'm going to test one on one side and test one on the other side. And if it works, great. And if it doesn't, then I just don't shade in that side. Okay, so that's kind of what you're looking for. Awesome.